Hello students. In our previous class, we had discussed about various type of mixture that were homogeneous mixture and heterogeneous mixture. Among this, we had discussed solution, colloid, suspension, etc. Today, we will discuss about the separation methods. So let's see, especially at first we have to see what is separation. So what is our topic today? Separation. Separation of the or separating the component of mixture. So here what we are going in separation, components of mixture. As we had discussed in a previous class, in mixture there are so many compounds or so many substances mixed together in various proportion. So today we'll try to separate them individually. So for this, in this topic, there are several methods of separation. Let's enlist them. At first, we will discuss about separating a volatile substance from non-volatile. Then second, there is centrifugation. Technique. Third, it is separating immiscible liquids. Then fourth, it is your separation by sublimation process. Then fifth, we'll discuss about chromatography. Sixth, it will be your distillation. Then fractional distillation, and at last it is crystallization. At this standard, this is sufficient. In further or in your advancing classes, we'll discuss or explore this more. So before discussing this, I would like to recall the previous methods which we have discussed in our previous classes of section 7. That was some physical methods by which there were separation of components from mixtures we usually do, like sieving. We used to have a sieves. Among this, depending upon the size of component, the small size component filter off or sieve off, and the large size component remain at the sieve. Then there was winnowing. With the help of air, the lighter particles will move away and the heavier particle will just down. In same way, filtration, cantation process, in which we allow a solution to settle down. We allow it to undisturbed. We just keep it undisturbed so that it settle down. And after some time, we try to pour the pure solution with the help of like this, with the help of a stick. Suppose it was a solution, then you allowed it, or suspension I should say, allowed it for some time. Then what happened after some time? There are impurities here and it is your pure water. Then you just pour it with the help of a stick or anything, so that you get the pure water in your container. That was the process of cantation. So there were so many processes which we had discussed in previous classes. So now explore the new methods of separation. So let's start with the volatile from non-volatile. At first, what is the meaning of volatile? If you allow something to heat, or if you are increasing temperature of something, what happened after some time? The volatile substance will just evaporate out, or it will just goes or leave your vessels in form of gas. It will go in environment, and the thing which is left behind is a non-volatile. So we can use this method. How we proceed this? There is an example in your book of separating ink or dyes. Actually, if it is of two color, what we do? We take it in a china dish. Okay, it is a dye. Then it's a tripod, and with the spirit lamp we provide heat. We never, one more thing, we never allow the heat directly. So for this, what we do, before doing this, we keep hot water in a beaker, and then it is your china dish, and here you are providing this dye. Why I was not putting it directly? Because it may charge. Suppose you are keeping or putting sugar on hot vessels, what happen? It will become black. So we are not supposed to do that. To avoid this, what we have to do, it is a hot water, then china dish you will keep here, and on this you will put a dye. What happened after some time in this solution? The volatile substance will leave it, and you will find the non-volatile substance, and now you can separate it out. So it was one method in which we can separate the volatile substance from the non-volatile substance. This method we can use to ink or some color dyes, we can separate out. And the second method, which is centrifugation. So let's see what is this. This we have done. Now let's see what is a centrifugation. The best example is your separating the butter from curd, or separating cream from milk. What we do? You have seen in at your home that what your mother do, she just churn it with the help of an instrument. She churn it, and after some time, or spun it very fast at speed. What happens after some time? The butter will come at the top of the solution, and at the bottom there is the curd. In the same way, the cream at the top of the solution, and there is a toned milk behind, left behind. So this method, and when we do it in our lab, we use the technique. This technique is known as centrifugation, and the instrument which we use is known as centrifuge. Okay. So centrifugation instrument we use, what we do, it just it rotate with a very high speed, so that the component of mixture separate on the basis of their density. The component with a high density will be at the bottom, and the component of lighter density will be at the top. So the important, or the principle behind this is what? What is the principle? Density gradient. Density gradient means the difference in density. Okay, means the lighter density component will be at the top, and the heavier density component will be at the bottom of the solution. So we use it, and in industries this technique is used very frequently. On the basis of this, we get a tetra packs of milk or polypacks. Polypacks mean the full creamed, or the tetra packs which is a toned or semi-toned milk, on the basis of this technique which we are using. Then let's see the immiscible liquid. How we can separate the immiscible liquid. What is the meaning of this immiscible liquid? The liquid which do not mix with each other. Means if we allow them to settle down, we allow it to settle down and we allow it at undisturbed. What happened after some time? We will find there are some layers of the different liquid. So on the basis of this, as they are not mixing with each other for a longer time, we use this technique. We keep it. There is a particular instrument we find. It is like this, and here there is knob present. Okay, knob present. And what, suppose we are taking oil and water. So what happened if it is water and oil? If we allow it for some time, oil will be at the top and water will be at the bottom. It will happen when we allow this mixture to settle down for some time without disturbing it. So if this layer we find, suppose this type of layer we are getting, here it is like this, and here it is. What we do, very slowly we'll open this knob and the whole water will be, we will collect it drop wise, very slowly we'll collect so that it will not disturb. And when the whole water will be coming out here, then it will be taking, the oil will take its place finally and the water will be here. So we can use this technique, or this technique is only applicable when the liquids are not mixing with each other, or actually they are immiscible. There are two types of solution, miscible and immiscible. Miscible means when it is not mixing with each other. Okay, so this technique is used here. Now let's see what is how we use the method of sublimation. In a previous chapter we had discussed what is the meaning of sublimation. If we are increasing the temperature in solid, directly turn into the gaseous form without changing in liquid form, then it is known as a sublimation. So there are some examples like camphor, or you call it kapoor in layman language, then anthracene, then ammonium chloride, naphthalene. These are the substance which show the nature of sublimation. If they are mixed with any other material or substance which is not which doesn't show the sublimation, then we can separate it out. How we can do this? We just it is your tripod, okay, and here you will put your split lamp, and here it is china dish in which you will put your mixture, usually in powdered form, so that because of this it is not easy to separate, and it is usually it is of same color also, so it is difficult to separate out. What we do, it is the mixture, then we cover it with the help of a this funnel, and here we put the cotton buds so that it will not leave the container. Then what happened? It is a mixture of sublimate and non-sublimate. if there is, we are increasing the temperature of the system, what happened? The sublimating substance, either these, it will just go here in form of gas, and here it will be usually collected, and after the whole it we had collected, we can separate out the non-sublimates from here and the sublimate from here. So this technique is very useful to differentiate or to separate the different substance which is of sublimate and non-sublimate nature. Now let's see the chromatographic technique. It is very useful technique in our biological lab, because this technique is used to separate the various type of drugs, different pigments, especially the chlorophyll A, B, or different types of pigments, that is chloroplast, chromoplast, or leucoplast, etc. And how this technique is known as chromatography, because chrome means the color. Chrome means the color. On the basis of this we do, and graphy, because we use the paper strip here, and we get the marks of different color substance on this paper. So we use this as a, we named it chromatography. How we do? Let's see. It is your paper strip. Okay. Here you mark with pencil. It is very important, with pencil you mark the original line or line of origin. Origin line. Point should be noticed, because that we always use the pencil to mark, because when we use the pen or a sketch pen or marker, what happen? It may be soluble in various liquids, either in water, alcohol, whatever, but the pencil will remain as it is. So our origin line will be remain as it is without disturbing. So it is your origin line. Then you put your mixture here as a drop or a point. Then suppose you have taken ink or black ink. Black. Then you put the black ink here, spot of black ink. Then you kept this whole paper in a water containing vessel, and its level will be just touching the paper, and this paper should not touch any wall of the container. With the help of thread we tie this actually, and let's remain it undisturbed for some time. You will observe after some time that as the water will move upward, because it will absorb the water, as the water will move upward, the ink, how many inks are soluble, or the components of ink, it is, we have to see, is there black is pure black, or it is made up of many components. If it is made up of many components, then the component will go with the water on the basis of its solubility. So here the concept of solubility in that particular solution which we are taking, solvent which we are taking, the more the affinity or more it is soluble, it will go more upward, and the less it is soluble, it will cover the less distance. So solubility is directly proportional to the distance covered by the component. Okay. So we observe that we find there are two spots, and here it is your water is, and there are the two spots. Means that black color ink is made up of two components. So this technique is very useful. We had discussed about this chromatographic technique. And now what is left? Distillation, fractional distillation, and crystallization. This technique we will discuss distillation, fractional distillation, crystallization. We'll discuss in our next part so that our class will no longer and it will be easy for you to study the separating method sequence wise without creating the complexity. Hopefully it will help you to understand the basis of separation of mixture, separation of component from the mixture. Thank you very much.